Today I want to show a preview of Kalpa, which is based on MicroOS and Kalpa uses the Plasma desktop, and I show the depth of the system as well. And here we begin how to install MicroOS, and then we also get the Kalpa version. It's openSUSE, and MicroOS is an immutable system, so it's a modern development, and to always make sure that you have a running system. And so it's working with btrfs and always copying the system, running the stable system, and the upgrade is only installed in a copy of the running system. So it's already in development, and normally MicroOS is more for server cases, and Kalpa is the version that you can use as desktop installation, as desktop system. So, and in future there will also be released a version with GNOME Desktop. There are informations on the webpage of openSUSE. So, but MicroOS is the core system. I also installed MicroOS with GNOME Desktop by myself. Just a minimal MicroOS installation, then going into the depth of the system with transactional-update, opening a shell, and then manually install GNOME as well. But this is not that common, and so the easy version, if you want to use the MicroOS as desktop, is just to install openSUSE Kalpa. You see here openSUSE Kalpa is in alpha development stadium in this moment. Offers KDE Plasma desktop built on MicroOS. Install apps using Discover. So and includes Podman container. So you have a safe and secure core system, which is automatically updating as well. And then you use Discover, Plasma Discover, for install applications through Flatpak. So this is the way. I click next here. Let's just type some stuff in. Use password and automatic login, for example. Next. Yes. And then you see here an overview what will be installed, and you can click also here on the header on software, for example, to change things. You can add some stuff more what you want to install or remove something out of it, but be aware what you are doing. It's better to go with the default and then just install. So I don't run the complete install here, but I will start it, I think, because it's need many time, I think, but it's from a DVD in this case, so it's running very fast, I think. But I have already running MicroOS, installed MicroOS, and I just started. Here you see openSUSE MicroOS, and here you have the snapshots, and for example here are a few snapshots. You see here kernel 6.19, and then kernel 7 is already coming in. We go back, advanced options. Here I can also choose between recovery mode or normal boot. So we normally just do the normal boot, and then I show some depth of the system. And I think afterwards I show a preview of the FRESH installation as well, because I did some modifications on this already installed system, and in a FRESH version some things are not that pre-configured like I did. Plasma desktop is loading, and here we are. This is Kalpa. I go full screen, and now you'll see this is console terminal in autostart. If you want to put a program into autostart, just create mkdir .config autostart, make sure this directory exists, and then just copy user share applications org plasma KDE. For example, many KDE applications. For example, we can copy then here's konsole. So the konsole desktop file, just copy it into .config autostart, and then you have autostart applications. But also here in the system settings, you have also autostart available. And here you see konsole is inserted, and you can here add another application. So just by the way, just a quick view aliases that I created to work faster with the system. This is here my system overview, the D alias, and then very similar the F alias. Then I have a dub for distribution update, but this is not working on this system. Was just then I have a lsblk alias and the L alias, for example. Then I have created an alias list updated packages today, which is just putting out in columns the today upgraded packages from varlog zip history. And then I have the syblog alias created, and this is this one, just to give an overview about the running transactional update service, and put out the last 65 lines from varlog zip history. So I can just look, is the update already installed. So this is just executing systemctl list timers, and then the transactional update timer, and then detail the status of the transactional update timer. So just to show you, so this is my D alias, this is my F alias. Then with S, I always clear the screen with this aliases, and then this is this. Here we see this is btrfs partitioning. The file system is btrfs. And here are the subvolumes. This is just a normal installation, and 9 GB available in this moment. And then we have the command sudo snapbar list for btrfs. I think, okay, yeah. And now we have a list of the snapshots. The system is working with btrfs file system, and btrfs is making snapshots of the system. And here we see now, today is May 26, and we see just in this moment the transactional update process was started and created a new snapshot. So, and here we see the asterisk sign is marking the current running and the default snapshot. So I know it's creating a new snapshot and updating the system in the background. So this is this command. There are multiple more things. You can snap remove and give, for example, 13 and 15, and then we tell him remove snapshot 13 and 15. Or I think also possible should be this version. This is the snapper command, but normally the system cares by itself about cleaning up the snapshots. You see here user data important, marked as important, yes. So there is the main command you use in Kalpa or MicroOS is sudo transactional-update, and then there is a command clean up. And now you see this command is just checking all the snapshots and marking which snapshots are important and which not, and deferring was there important changes in the system or not, because sometimes you can have a small new snapshots that isn't importing as well. And there is a configuration in the system how many snapshots are holded, and then the oldest snapshots get removed. And I think, let's check, what was it? I wasn't sure. Normally, history, here, 256, this file, etc snapper configs root. There we have the configuration for how the snapshots get cleaned. I don't go into the details, but just to show you, you see all the stuff also in the documentation of openSUSE. And here you see number cleanup is the mode, how to clean up. It's checking the numbers. Then minimal age is 3600. So it's checking the snapshot has minimal this age. And then here here are the numbers. The normal numbers are 2 to 10, and the important ones are 4 to 10. You can do modifications, but I just do a deep view into the system, so some background stuff. Normally, you don't need this if you just run Kalpa. It's just running and it's okay. Timeline cleanup as well, and yeah, I think that's it. So most important is if you really want to make changes, you can modify this lines number limit and number age, but normally you don't have to. Just to show you, there are the configurations how the snapshots are maintained. And now we see here we have a change. Now we see 20 is marked with a minus. This is the current running snapshot, and 21 is marked with a plus. This is a new default snapshot which will be rebooted when we reboot the system, which will be booted when we reboot the system. So this is about the snapper. Then sudo transactional-update --help. Let's pipe into less, and this is the main command for modifying the system in the dep. Here we have the cleanup command. Here is also grub.cfg to regenerate grub.cfg. We can also make modifications on grub.cfg, and then we have to use the transactional-update command to regenerate the grub.cfg. Because when you want to make changes, you have to write it into a new snapshot. So if you make changes on the system and don't use the transactional-update command, you reboot, the changes are gone, because the core system is made secure. Okay, and then we have reboot. It may be helpful when you just want to update the system and reboot afterwards, for example, the manual way. Okay, and then we have the package command. So this would be transactional-update and then just dup, and so you can combine, for example, make the dist upgrade and then set before the general command reboot. Also, it's possible to just run one command in a new snapshot, and the most important may be also start a shell. Open a read-write shell in a new snapshot before exiting. So, and this is an option where you get a new snapshot of the system and then can apply changes within. When you make multiple operations, then this is the best way. Okay. Then also you can set the rollback to an other snapshot, and here's a simple command rollback last, or you give the specific number to which snapshot you will roll back. So this is the number which you get with sudo snapper list. Okay, and then what I like is the --continue option as well. Here you can give also a number on which snapshot you want to work. When you, for example, open a shell with transactional update, or you just use --continue or -c to work on the last snapshot. So this is important when you, for example, running the system and the system was actually updated but not rebooted, then you have to use the --continue option. So I show you. Snapper list. In this case, the system is running on snapshot 20. So we have to reboot to run the 21 snapshot. And when I say, okay, I just want to make changes within this snapshot before reboot, then I have to use the --continue option. Okay, sudo transactional-update. Then we use the option -- for example, you use reboot. I'm not sure. Can you use reboot and dup? Maybe, I'm not sure, but normally you don't care. I show only the manual way here. So open a shell. We use --continue and then open a shell. And then you will see he opens a shell in this new snapshot. Otherwise, when I don't give continue, he would create a new snapshot from the current running snapshot. And then it would be the case that we have two different new snapshots. This with the system update and this where I just start the shell. So in this way, this is just important. Just work on the snapshot where you have already executed some system changes. Okay. So transactional update continue shell. We open a shell. Now we see we have a login, a shell with another bash prompt, and transactional update started. Continue shell. Here you see using snapshot 21 as base for new snapshot 22. So he is creating a new snapshot, but using 21 as the base. And if we don't use the --continue option, he would use the number 20 as base. So that's it. And now we just can use, for example, the zypper command. And zypper ls is just giving listing the repositories. Here we can also enable and disable some repositories. And here you see it's using in the depth of the system, it's using tumbleweed within. And this was the MicroOS DVD. I think so. So you see here 3 repositories are disabled. So then we can just use dist upgrade again. It's just checking, and then he says there's nothing to do because within the new snapshot all the updates were installed. So now we can install a program, for example. Let's check. VLC, htop. Yeah. Maybe let's check. Do we have what was this? Featherpad. Yeah. Let's install Featherpad, for example. Now we install a program, Featherpad, and we install it in the core system. In this case, this is not the usual way. And we remove, for example, htop. Now we install a program, we remove a program, and can we install as well bash top? No provider, but btop. Yeah, btop install. And now you see we installed Featherpad and we installed btop. And now htop is already here available because we stay in the current running snapshot. We don't get the changes immediately, instantly. And btop is also not available here. And Featherpad is also not available here. So we have to reboot to get the new installed programs, okay? But this is not the normal way to do it, but it's how I like it to do it. because some important programs I like to run within the core system as well. But the whole concept of MicroOS is mentioned to be to separate the core system and the installed applications. So we just made now some changes with zypper within the core system, within a new snapshot of the core system. And then we just exit this transactional update shell. And now we see transaction completed. Exit status is 0. So this means 0 errors. This is also important to check. If there is an error, you have to check the details, what was going wrong. And then we get also close snapshot 22 using snapper as snapshot manager. New default, and here this is important. New default snapshot is 22 here. Okay. Please reboot your machine to activate the changes and avoid data loss. Now we execute again snapper list. Now you see the current running snapshot 20, the new 21 snapshot, and then we have the 22 snapshot with plus, which will be booted after reboot, and the plus marks that it is the new default. And here we see the 21 snapshot is an update of the number 20 snapshot, and this is an update of the 21 snapshot. So, and if I would start a shell without the -- continue, I just show you. Now you will see. Now you see it's using the number 20 as snapshot, creating a snapshot 23 with a base of 20, and this is what you normally don't want. Only if you have a snapshot where things gone wrong and you think, oh no, I don't want this snapshot, then you go to another base, okay? Or you give -- continue with the specific number from which snapshot you want to continue. In this case, I do nothing, close this, and then list. And now we see we have again a new snapshot from 20. And this is what we don't want. But this is now marked as default, okay? So there's also an option to set the default snapshot with sudo snapper. In this case, we want to set the snapshot 22 as a new default. How to do it? -- help, pipe into less, and then sudo list, create, modify, here, sudo snapper modify, and then default, and then give the number. This is a command. Sudo snapper modify, with tabulator key you can do the bash completion, -- default, and then we give 22. So again, sudo snapper list, and now we set the 22 snapshot to the default snapshot. And we could also remove the 23 with delete and then give 23, but make sure you know what you are doing. I don't do this in this case. We just do the restart, and then we see the changes. So this is about the core system. Just to show you flatpak list. Here we see the installed programs which are installed with flatpak. So this is a separated system. You have the core system working with transactional update, and then you have on the immutable core system, which will be updated manually, automatically, you can install your programs with flatpak and update them manually. And so the core system is untouched and is secure and safe. And you can manually install with flatpak some stuff and deinstall and do whatever you want. Just to show you flatpak, we can also do manually update, flatpak update, but I show you we have here information updates available, and these are the updates within Discover, Plasma Discover, and Plasma Discover is only managing the flatpak updates, okay? Here now we see some updates are available, okay? I just close this in this case and do it manually in the terminal just to show you. Here you get the same overview. These packages get updates with flatpak. Okay, and now I can execute, or I could do it with discover. I just execute it within the terminal. So you see both sides within the terminal or within discover. And now you see the information is gone, updates complete. Let's open discover again. Updates, refresh, and then we see all things are up to date. So this is about flatpak. And then there's also available distrobox. So I showed you the depth of the system. You can also install programs into the core system of MicroOS Kalpa Plasma version. But normally you use flatpak, and then you can install also distrobox. And I show you sudo, no, not sudo, distrobox --help. Now you see distrobox version, and then you have assemble, create, enter, list, remove, stop, upgrade, and so on. And now we can, flatpak is for the graphical user programs, and distrobox you can install a separate image of openSUSE tumbleweed in the terminal to get more terminal programs and work with different boxes, distroboxes as well, and copy them and so on to develop things, test things and so on. So let's do distrobox ls, and then we see no distrobox is here available. And then let's just create a distrobox, and we don't give a name. You can give a name, and there are more options. --help, and then you see all the options. Distrobox create, you can give a specific image. For example, you can also use ALPINE or FEDORA, and then you can use Docker images as well. You can clone an image from an existing distrobox. So important maybe with --image you give a specific image. Here you see this is the default, which is just using an openSUSE distrobox image, which is openSUSE tumbleweed, and with name you can give a specific name. Default is my distrobox. Then you can set the host name for the distrobox as well. Default is Kalpa. And so this is most important, I would say. Name and host name. --name, --host name. And I make changes, and I just rename this for my case. Create --name tumbleweed box, and --host name also tumbleweed box. And then it's pulling the latest distrobox for tumbleweed. I don't give a different image name or image source, so it's just using the default. It needs some time. And now it's pulled, and we can now enter the distrobox with this command. Okay, distrobox, and then we can list, or ls is the same. And now you see we have only one distrobox. Let's check df-ht btrfs, and we see 8 GB available. Okay, that's fine. And now we can just enter, and then you just can use the tabulator key, and it's only completing the one existing distrobox. So this needs some time because now it's starting the container and initialize and installing the basic packages. Because the pulling is only pull the basic image, and now it's really initiated. And now we see we have tumbleweed box is now the host name. I open a new tab. Here you see on the host system, Kalpa is the host name. And in the distrobox, we now know we are in the distrobox. But what is important, within the distrobox it's already using the configurations files from your home folder. So it's using your bash rc from your home system. And I just show you nano.bashrc. For example, this is the bash rc, and I put in here the ps1 and source the bash aliases, and then give the f alias, and then just an echo command. This is happening when I open a new bash, and this is the output. Okay, this is configured by myself. This is my f alias, fast fetch, and then my system overview with colored output. And bash aliases, these are my aliases. Okay, just to show you again, alias d, then s, k, l, cv, grep, na for nano, and then the u and dub is not important in this case because we work with transactional update. You cannot directly access zypper in MicroOS. And then the zip lock I want to show you as well afterwards. So just to show you, and this bash rc and bash aliases are also used within the distrobox. It's using your configurations from your main system, but you have a new box where you can install applications, and also it's possible to install an application and make it available in a graphical way, for example. And now we can, within the box, we can use the zypper command, for example, zypper list, and now ls. Okay, this is possible, and now you see it's a different output of the repositories. Because we work here in the distrobox and not on the host machine. So this is a secure environment where you don't touch your host system. And this is the great point about MicroOS, immutable system. This is also with FEDORA Silverblue, very similar. The core system is separated from the working system where you can make changes and create different distroboxes and try things. So you don't break your host system. This is very good, okay? And now we can, for example, install fast fetch and we need sudo, okay? And then we install fast fetch within the distrobox. And now we can use the alias from the home directory, and then we get the similar output. But here is different because it's within the distrobox. We have some different mount points. And also you see the output is different from fast fetch because in the distrobox it is directly tumbleweed. So fast fetch is showing us tumbleweed. And on the host machine it's showing MicroOS because the host system itself is not is using tumbleweed in the core system, but the host system is a primary MicroOS with the separated partitions and btrfs system and so on. So this is the reason, okay? And now we see also my alias is not working well in the distro box because we don't have uptime, the figlet command here, and the uptime command is not working in a normal way here. So we can install figlet as well, and now we get figlet in the distro box and then execute. And now you see we have openSUSE tumbleweed here shown, and on the host system it's openSUSE MicroOS, and this is just alias d. Alias d is just grabbing from the file /OS release, okay? And I just copy this, insert it, and execute it manually, and then you see this is the output from the grab command within the file /OS release. And this is a normal entry in this file. And if I cat out this is the MicroOS release file with all the stuff. I just grab the line and then I put it into a cut command to only print the part after the equal sign, and then with the set command I just delete the double quote. So this is just to show you. And because we have in the here on the host system, this is the output MicroOS in the MicroOS release file, and in the in the distrobox, the MicroOS release files is different. Okay, there openSUSE is tumbleweed, and this is how you see we have created a system within the system. Okay, so I hope this is a bit clear. But it's also a bit complicated when you are not used to use this. I also need my time to understand how this works. Okay, and now I know there is W. W is using is giving out also the first line, which is on the host system the uptime command. Uptime command. This is this line. In the distrobox, uptime is not working, so you can use the W command and, for example, use W pipe into head-1, and then you get also only one line. So I can, for example, I can put into my alias a difference because checking the host name, and depending on the host name, I use this command or I use command. I could do this, but I don't do it in this case. It's just using too much time here. So let's do sudo superlist. No. ls. I know, I'm not sure which command was this. Clean repos. Install, remove, verify, list updates, update patch, list upgrade, search. Yeah, I think we can use the search command. Search, and then you see all the packages are listed that are available. Okay, so this is really many packages. Again. So, and now we can pipe it into word count -l, and so you see all available packages of yeah, I'm a bit confused here. 56,000 and a few. And now I just grab beginning of the line and then pipe it into word count. And now I just grab the only installed packages. And now you see 361 packages are installed within the distrobox, or what's with the cursor. And on the host system, you see, for example, here fastfetch gives out 6 installed packages on flatpak, and rpm installed 1605. Okay, so this is just this. We can also use here. Here you see in the distrobox 363 installed packages as well. So sudo super search, we can search packages, and okay, what have I done? And then just put out only the installed packages, and this is not very good in this case. We can use this and do it again. Oh, it's also not. Now you see very small font, but you see then all installed packages within the distrobox, for example. Okay. And then you can install whatever you want. Search, super install htop, btop, and so installing terminal programs in distrobox is very easy and fast. You don't have to reboot the system and so on. The core system is safe. Starting htop in the distrobox, for example, is also a bit different than on a host system. but not that different. And then start btop is directly available in the distrobox because we have installed it. And on the host system, we don't have btop. Okay, you see, this is a different. Top command you can use as well. Okay, I like the top command. Okay, so use the distrobox to install multiple programs. I think we also could install a graphical program, but we have to make it available in the host system. And there's also a possibility, here now you see we have an entry in the menu for tumbleweed box, and we pin it to the task manager, for example. Okay, so I exit the distrobox. Now we are back on the host system Kalpa and distrobox ls. Now we see it's in green color, and this means it's already running in the background, the distrobox. Okay, we close the terminal here, and now we can use utilities tumbleweed box. And now it's starting the console terminal within the box directly. So this is how we can work. Start the distrobox directly with the terminal. Okay, so I start console, we are using host system Kalpa. I start distrobox, we are using tumbleweed. And if I would install a box, let's for example distrobox create name Debian hostname Debian box, and then a image, yes, show all available, and then we could have an overview, and then we can use a Docker image, for example. What is this? Docker image and toolbox image. Okay. Oh. Is this important? Let's use a Docker image. Debian testing. No. Debian testing. Let's check. Now we pull the image for Debian testing, for example. Creating the image. Successful, created. Distrobox list. Now we have two boxes, also a Debian box. Okay, well, let's go to utilities. Now you see we have here a Debian box. Let's pin to task manager. So we have two distroboxes. And you know, I would say let's try as well QK FEDORA. Can we put in directly FEDORA? And now you see it's pulling the latest FEDORA image. Okay, utilities, and now we see we have also a FEDORA box now. Tumbleweed, Debian, FEDORA. Okay, ALPINE. Let's check ALPINE. ALPINE. And now we get the latest ALPINE Linux image. And we have now an ALPINE box. Here is the ALPINE box. Tumbleweed, Debian, FEDORA, ALPINE. Okay. And now distrobox list. Now you see 4 boxes are installed. Okay. Enough disk usage is available. And now we can just enter manually Debian, and it's getting initialized at first. Need some time. And I start now also the FEDORA box as new terminal. Maybe it's too much. And it's also initializing the FEDORA box now. So I think it's pulling many stuff from the network load in this time. System monitor, let's check the system monitor. Is the system monitor? Okay, here. I go out of the virtual machine and go back, and now we see the installed system is rebooted here. I'm not sure in this case. Maybe the installation image was a bit old. I'm not sure about this. But normally I manually started the sddm login manager in this case. And this is a fresh installation, okay? Oh, we have two machines here running. But it's a bit... Okay, back in this machine. Now we see... okay. It's already initializing. Okay, FEDORA box is initialized. Let's start the ALPINE box as well. Now we have three terminals, and here you see FEDORA, ALPINE, and this one. Installing basic packages. Disk space already available, this is okay. ALPINE box initializing. So this is heavy multitasking here. Okay, Debian box is also initialized. And now I close this terminal again, and I open the top command, TM to get the bar, right, and header 4, task, nothing, right, top command, system load is running, ALPINE box, FEDORA box. ALPINE box. So let's start the Debian box. And now you see we have multiple boxes here. Okay. The host system terminal, the FEDORA box, the ALPINE box, the Debian box. Let's go in the FEDORA box. And in this case, interesting, this is a Docker image. This is a different. Normally Distrobox uses Podman, and Podman and Distrobox, Podman and Docker images are different. Podman uses also the host user configurations, and the Docker image is accessed as root image, I think. So this is why I don't have available here my home aliases in this case. Okay, but we can, for example, sudo dnf update and nothing to do. Install, let's install fast fetch. Now you see we install fast fetch. Okay, here I have to type y manually, and then fast fetch. Here you see FEDORA. and then distrobox Debian sudo update. One package can be updated, upgrade. Okay, just to show you, install fast fetch. And then fast fetch Debian. Alpine box. Alpine is different. doers command apk is a package manager, and it's not install, it's add or update. Oh, doers is not here. Why is this? Maybe it's sudo. Okay, in the box they use the sudo. On the original Alpine, it's the doers command. And now upgrade. Update is refreshing the repositories, and the upgrade is upgrading the packages in Alpine Linux. So, and the add command, the add argument is installing packages. Fast fetch, for example, installing fast fetch. Alpine is really fast, absolutely fast. Now you see Alpine, okay? And so we have here Debian, FEDORA, Alpine, and the host terminal. I close this, and then I just show you this, and oh no. So let's put it smaller. That's it. Okay. That's it. No. So, and now you see, okay, let's open a new window, and now you see, yeah. Now you see we have MicroOS host system, Debian, FEDORA, and Alpine. Amazing. So, and this is possible with distrobox, running multiple Linuxes within one host system. Let's use the main terminal again here, and a bit bigger. Distrobox ls, and now we have 4 boxes running. Okay, and now we can also stop the box. Stop, for example, Debian, and then stop FEDORA, and then we list again, and then you see 2 are red and the other ones are green. Stop Alpine, and at least we stop also Tumbleweed, for example. And then it's look, all are red and all are stopped. So this is how you can work with distrobox. And also, let's try again. Then we can remove, I think, rm command. And then, for example, let's remove FEDORA. And then container is removed. 6 is available, and now we have 0.7 gigabyte more space available, and only 3 boxes here. Let's remove Debian. Now we have 7.4 gigabyte free. So you see, it's a bit less than 1 gigabyte for the distrobox, 700 megabyte or so. So you see in the toolbar also the toolbox icon is empty now. So. Okay, just to show you, this is impossible. We remove Alpine as well, and then we have 7.9 gigabyte free, and we have only the Tumbleweed box now. So normally, for normal cases, you just create a distro box with Tumbleweed in openSUSE, and then you can install multiple packages in the terminal separated from the core system. Okay, this was a really deep dive about this. And now So this is it. You have the core system with transactional update and opening a shell, and then you can use your flatpaks for the graphical programs, and then you can use the distrobox to install multiple terminal applications. And what would also be possible is, I want to show you sudo snapper list. What we also could do is, why it is using so much time? Okay. Here. Now we have these. So let's install into the core system the btrfs terminal as well. Sudo transactional-update dash continue, and we use 22 snapshot, and then we do package, was package, I'm not sure, can I install ptxs? No, not possible. We have to use the pkg. Okay, so we use pkg install, and in this case I use now the snapshot 22, continue on this snapshot, and we use the package command pkg install a package. And now this is different. I don't open a shell like I showed before. I directly install a program. Okay, now you see, continue on snapshot 22, create snapshot 24, and then we see without colorful output it's installing the btrfs terminal as well. And now we get the btrfs terminal after the reboot, and I want to show this as well, because the btrfs terminal is very helpful also with working on distroboxes. Just another way, but they implemented this very well here, I think, with the desktop entries to starting directly the distroboxes here. Okay, just to show you, I start the distrobox again, and then you see distroboxes started. Here's the distrobox. This is within the distrobox. Logout. So now we have the snapshot 24 is a new default snapshot, and now we could also remove the 23. Just to show you, transactional update, we execute the cleanup command, which will be executed automatically normally. And now you see that he is marking the 23, 22, and 21 for deletion. I don't know why exactly, but he's doing it. List again. And now we see, yeah, that's it. And I think because he's doing this because we worked on each snapshot. We created a new snapshot from 20, then we used the 21 snapshot for a new one, and then we used the 22 snapshot for the last one. And because the last one is our default, and it's all a copy of the previous snapshots, we don't need those other snapshots anymore. And this is why he marked them as for deletion. Okay, and so, okay. Oh, this is really much, because it is really complicated and complex. So this is a snapper output, and you have multiple services running in background, which are cleaning up and upgrading the system automatically. And now we come to the core system. Okay, and I have here created the alias list upgraded package today, and now you see this is showing us all the upgraded packages from today. this is just this alias here. Okay, this is I use for simple overview. Then I have an alias sublog. This is this alias. Okay, and then let's execute this. And now you see this is the output from my alias here. So it's just giving the last output from the log of zypper, which packages was installed. And here we see btrfs is installed at least. And then I have the output from the list listing the timers. And then we see transactional-update.timer is here. Okay, and the transactional-update timer is executing the transactional-update program to upgrade the system automatically and also clean up, I think. And the timer is just running at first to check the time when is the next time to execute transactional update. So this is because the timer. And we can make changes on the timer with an override configuration. Okay, and this is in etc systemd system transactional update timer directory. We have an override configuration file, and I created by myself this file and edited when the system should be automatically updated. Okay, and normally it's happening in every night between 1 or 2 o'clock, I think, and it's automatically happening every 24 hours. This is the default setting, and this is why he is waiting 8 hours left to the next trigger for this timer. So at directly at the next day 0 o'clock. Okay, and you see here the status is just a white. Okay, this is not running, and so it's just a white point here. Yeah, it's executing the transactional update service itself. So the timer is triggering the service to execute. Now I show you sudo systemctl. Status is just the main command to list all services, and then we can manually, let's execute this again, and then we can manually status transactional update. And then you see this is a transactional update status, and it's different from .timer. Now you see sudo systemctl status transactional update timer. This is the output, and this is the same I put into my alias here before. Okay, so this is a command to manually check the transactional update timer. And then you also can use list timers, and give the specific timer, systemctl list timers, transactional update timer. Okay, the normal output is list timers, is listing all the timers, and now you see we have multiple other timers. We have the snapper timeline timer, snapper cleanup timer, and this is snapper cleanup is cleaning up the snapshots from btrfs. So it's cleaning depending on the marking of the cleanup we did before, for example. So transactional update timer is executing the update, and the cleanup is then cleaning the snapshots. So you always get again space freed because some old snapshots are getting deleted. Okay, so you don't have to do it manually normally. It's all happening automatically in the background. And we see 41 seconds ago, so the snapper cleanup timer was executed, I think. Let's check. Yeah. And so just check snapper list. Okay, you see all the snapshots are already there. If the next time the cleanup snapper cleanup is executed, then he will remove the unused snapshots here. Okay. So that's it about this list timers. And then I want to show you, you can now status transactional update timer. And what you can now do is you can edit, systemctl edit transactional update timer to make changes when transactional update should run in the background. And you see here, this is a normal default file. And the default file you can read in the documentation about systemctl, about systemd and systemctl and the timers and so on. And here you have on calendar daily, accuracy 1 minute, a randomized delay, and then persistent true. So the most important is here randomized delay 2 hours. So it's it's happening daily. So it's checking every 24 hours. And then we have also a randomized delay 2 hours. That means after reboot, when the last timer was executed more than 24 hours ago, he's just executing the transactional update timer within the first 2 hours. So I don't like it because it's a virtual machine. I don't run this each day for hours. So 2 hours, I don't want to wait 2 hours. So the update is happening in the background. So I did change this for my needs. And this is here on the upper part. You see here the comments, editing, system override. This is the file. Anything between here and the comment will be become the contents of the drop-in file. And important is here, you also have to put in the section. So because the randomized delay part is in the section timer, I also copied the timer section and then the direct option I want to change. And then I changed the value to 20 minutes. And this is happening now when I start the system, and the last time is more than 24 hours ago. In the first 20 minutes within the randomized delay, it's executing the system upgrade in the background. You can also set this to 40 minutes or 1 hour, however you want. You can also let this be in 2 hours. It's depending on your needs. So just to show you what you can do and change in the system, set your preferences for the automatical update in the background. Okay, I like this because I like this setting in this way. It's working well for me because I also like that the normal upgrades happening automatically in the background. I could do it manually. Manually would be sudo transactional update and then just the dist upgrade command. But I don't execute it because I had to input continue as well in this case. So, but all things are happening fully automatically in the background in the normal way. You have only update the flatpak packages manually and the distroboxes as well. Okay, I hope this was helpful. This is really a deep dive and I explained too much. But maybe someone is interested in this, and I experienced this very deeply and know now how the system works in the depth and how I can configure and work with the snapshots and work with transactional updates. And so I really like the concept of MicroOS and immutable systems. You learn many things when you go into this and make this work well. So you experience much things, and this is what I like. I want to grow in skills and knowledge, and this is why I do this. So now at least let's reboot the system. Also per default you don't have this icon here. I just configured it and I just searched applications all, and here you see distributor, and then you find the Aeon icon. This is upcoming MicroOS with GNOME Desktop, and then the Kalpa icon and the cubic icon and the slow roll and tumbleweed and the MicroOS icon. So I choose the Kalpa icon manually, and then it's looking this way. Let's restart. MicroOS. And now you see snapshots. We have a new snapshot here available. Okay. If something is broken, you just start a read-only snapshot. I think they get started read-only, I'm not sure. But you start a snapshot, then you check is everything working, what you wanted to work, and then you choose the correct snapshot and set the new default snapshots with sudo snapper modify -- default and the snapper number. And then you can clean up and remove a snapshot with failures. So restarting Plasma. I would say the system itself, it's a bit, the boot of the system is a bit slower than Debian and so on, the normal distributions. But if you work with the system and so, it's working well. Now we have also available space here. This is fine. Now I want to show you. We have no more htop here. And we have now featherpad installed as well, because I installed featherpad with transactional-update in the core system. Okay, featherpad is just an editor here, small editor. And in system now we have also btop in the core system installed. And what is good, when you install some programs into the core system, which you really need, they also get automatically upgraded. This is what I like as well. And btrfs is now the terminal I also installed in the core system. Here. And this is btrfs. I don't know if I... so. And also GNOME console is available as terminal, but btrfs is good in this case that you have here listed in the menus all your distrobox containers. So you can just directly click here in the menu and start a new tab with your distrobox. This is what is nice about btrfs. It's easy to work with different distroboxes. It would also list here the Debian and ALPINE when I haven't deinstalled them. And you can also get an overview of your tabs as well. So just to show you, this is a special terminal which is optimized to working with containers. Also, is you can create a new terminal. Okay, this is just a tabulator button here. And also you can do preferences, and you can also create profiles here. Add a profile, for example, edit, name it, for example, tumbleweed box, and then you can set some stuff, and here you can change to the tumbleweed distrobox, for example. So, and this way you can, for example, use the tumbleweed box and give the whole terminal a different look and a different, for example, you set here, I don't know, Capuchin latte as color palette, and now you have the tumbleweed box as a profile as well. So, and I think, yeah, now you see we have here listed the containers, and we have here listed the profiles. And if I click tumbleweed box profile, you see now we get a white terminal in this case. And if we switch the tab, it's also switching the profile. And so you have also more visible, okay, now I'm in the box, and now I'm on the host system back. And this way you can do the changes. And also the colors are different, a bit different here. But I also use the host name is also very remarkable. So let's close this, and now we are here. Box S. You see this is our distro box. And I think, yeah, distro box, enter, And now let's go in, and I think we could also do sudo zypper in, let's do Chromium. In this case, we can also install Chromium in the distrobox, for example, but I don't want this. This is way too much for my needs. Let's do install food. Food terminal needs not that much. I just want a graphical program. Can we do GNOME text editor? Also possible. Just to show you, we installed a few graphical programs within the distrobox, but we don't have them in the menu on the host system. And normally there should be distrobox-export --help. And now let's check app GNOME distrobox. But I don't know, can we app GNOME text editor? And yeah, now you see utilities, and the text editor is now available. Graphical program installed in the distrobox. GNOME text editor. Okay, and so this is the way, pin to task manager. Now we have GNOME text editor from the tumbleweed box. And now let's food system, and now we have here food terminal on the tumbleweed box as well. Now we have here food terminal from the tumbleweed box. This is the food terminal. Okay, food is also amazing. It's a Wayland only terminal. So with this command, distrobox-export app and then the app name, you can export an application from within the distrobox to your host system and can use this on the host system. So this is also a good way to get graphical applications not only from Flatpak but from your distrobox. And this way you can, for example, also create distrobox, create FEDORA. Need some time, maybe. Okay, distrobox, enter FEDORA, and then we enter the distrobox FEDORA again. Okay, this needs some time, but it's working well. So and now we are in the distrobox. Sudo dnf update. Oh no. Okay, now I close btrfs, and now we should have here the FEDORA box as well. Let's start the FEDORA box with console terminal, in this case ls. Okay, I did not change the host name. This was the error. Okay, so let's do again. Distrobox, remove FEDORA, and then create FEDORA again, and we give host name FEDORA box name FEDORA box, and then we pull the FEDORA image. No, this was wrong. Something was wrong. Why was this now? Create name, host name, and then --image FEDORA. This is important because he used again openSUSE as image in this case, because I missed the --image. And now using image Fedora, now it's working. So, and now distrobox Fedora, but normally it should be available from the menu. Now here's Fedora box, pin to task manager. Okay, close, and now let's start the terminal Fedora box. Initializing. Need some time. So we can unpin btrfs and unpin this. Now this is this sudo dnf update install fast fetch and okay. Bam. Let's dnf install. Let's install featherpad. Oh no, this is too much. Vim. Now maybe install. What would be possible as well? Let's check. GNOME console, another terminal, for example. Oh no, this is too much. Food. Yeah, okay, let's do this. And now just to show you the difference again. And now we can use again distrobox-export --app food. And now we export the food terminal from the distrobox. And now you will see we have multiple food entries. Now you see food on Tumbleweed box and food on Fedora box. And this is different. Okay? This is this. This is food with the Fedora box. And then we have food on Tumbleweed box. And now you see that's it. The one terminal is starting with Fedora and the other is starting with Tumbleweed. And both foods are the installed food within the distrobox itself, okay? So we also could install Firefox. Oh, this is way too much. Falcon. This is also very, very, very much. So we have a smaller one. Epiphany. Yeah, it's a bit smaller just to show you. So now we install the Epiphany browser. You also could install archlinux box. Okay, distrobox create --name archbox --hostname archbox --image archlinux. Now it's pulling a container for archlinux. So this is ready. Distrobox export Epiphany. Okay, here --app, and now we have the Epiphany app also. We have an archbox installed. So, but now let's choose here the archbox. Let's pin to desktop, and then we have internet Fedora box, web Epiphany browser from the Fedora box. Okay, now we can start the Epiphany browser, which we have installed in the Fedora box. Here we are. This is the Epiphany browser. Okay. Just to show you. And then we can close this one. Let's start the Arch box. Okay, installing base packages and so on and so on and so on. Let's go into the host system. List upgraded packages today. This was upgraded packages, zip log alias, and this is this. Okay. Archbox is now initialized. And here we use sudo pacman-syu to update. And -s we use for, or -sy for using fast fetch, for example. And now pacman is installing fast fetch. Firefox 800 megabytes. I don't want to install now. Epiphany. Oh no, yeah, it's okay. Enough space here. Pacman is really fast. You see this? Pacman is the fastest package manager. Boom. Here we are, fast fetch. And here you see this is archlinux, the Arch box. And now we can distrobox-export --app Epiphany. And now we have also Epiphany installed. Now you see two entries of Epiphany, one with Fedora box and one with Arch box. Here we are. This is Epiphany from the Arch box. And when we get about web 40.4, and let's start from the Fedora box. 50.4. And now let's close. Maybe we have to close first and start then the other one. Okay. And then about web. It's also 50.4, the same. But if we would install a Debian box, it would be different. But now you see this is how it works. Installing Fedora, Arch, and all those things. Okay, that's it. I think we stop here with this one. Many examples here. And also, let's do distrobox ls, and then we could remove Fedora box, removing the container, and then you will c-ht btrfs head-2, and now you see 5.8 gigabyte available. So we get 1.4 gigabyte more space by deleting one box. So, and you see the this is again gone. The web Fedora is gone, and as well here the Fedora entry is gone. And now we have only the tumbleweed and the Arch box. So, okay, just different examples. Very, very, very long deep dive. openSUSE MicroOS Kalpa. And now we shut down this machine, and I show you some stuff on the fresh installed machine at the end. Okay. Here, this is a fresh installation. And you see screen resolution is not correctly, and so on. We go in the system settings, display monitor, and then we choose this one, apply, keep, and then is this one. Let's go full screen. And this is a new installation, Firefox File Browser. And here, utilities, the system, applications. Let's put it to the pinned here. Info, multimedia, internet, help, development, favorites. Okay. So let's open the info center. And here you see from April in this case. So this machine is not upgraded in this case. The kernel is old as well. So let's open the terminal. And then we check the things again, how the original configurations are in the system. df-h t btrfs. And here you see all the btrfs snapshots, lsb lk-f. Okay. Here also file system btrfs and all the btrfs subvolumes, not the snapshots, subvolumes, and lsblk, and this is the normal lsblk output df. So, and now let's check systemctl status transactional-update.timer. Here you see now transactional-update-timer is active, waiting 10 hours left. Because the system is fresh installed, he's checking for the next update in multiple hours. Okay, and if we copy this and then just cat out, here you see the settings from the transactional-update-timer, like I showed before. And here you have the randomized delay 2 hours per default. Okay. And again, if you want to make changes, then you type the edit command. Failed to create parent directories for permission denied. You know why? Sudo is important. And then you can put in here the lines. For example, copy. Oh, and then it's vi in this case, and then just copy, and then just remove, and then go to the end, and then here we insert 20, let's choose 12m minutes in this case, and then we write the file, and now we have overwritten a setting for the transactional update timer. Okay. So status again, nothing changed because we have to restart normally. Reload or reload. So okay, reload is not possible. Restart. And now we have restarted the transactional timer. And now already 9 hours are also left. Okay, but we don't care. So let's check manually. Sudo snapper list. Now you see also here the sudo input is in a graphical way. We could change this if we install another package with sudo. And here you see we have only one snapshot here. First root file system, okay? df-h head 2 and 9 available. So now we have sudo transactional update, and now we can enter a shell, for example. And now we are in a shell, and now we can super search sudo. Now you see all the packages with sudo, and here, for example, we see nothing installed exactly. You can install the system group sudo, for example, as well. And here's also available sudo policy sudo authentical self. This is also possible to install. I don't know why he is not showing the sudo command, but this is possible. I think you can install the sudo command and the sudo policy sudo authenticate self, and then you would get grep I. Okay, you see also branding, distribution logos, and so on. Okay, wallpaper branding. Okay, I don't know. I haven't. But yeah, it's possible to change the sudo type in password prompt that you get this directly in the terminal and not the graphical pop-up. But not important here. Zypper. Let's zypper dup manually, and now you see we can manually upgrade the whole system as well, all the packages. So this is really, 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 really much, because it's 2 months ago. 1 gigabyte. Let's execute this in this case. So now system upgrade is running, preloading packages. So, and this system upgrade is normally automatically executed with transactional update, but you can do it as well manually. So what we can do also here in Plasma, configure application launcher. And then we have here MicroOS logo, for example. MicroOS logo. I choose a different one. All. And then Kalpa. This is a Kalpa logo. Can make it a bit smaller. We can also disable the floating. Then we have the panel per default here. So the update is running. Verifying. Here in the system status notification, you can configure the system tray, and then you can show only in pop-up, for example. Show only in pop-up, and show only in pop-up, and then show only in pop-up. Then you have a very clean system tray. So installing needs some time, but we also could check sudo flatpak, but it's not important. Flatpak list, and here you see the default applications which are installed in Flatpak. So we can also execute a Flatpak update. Looking for updates, nothing to do, the Flatpaks are all up to date. Maybe it's after the installation, it's directly updating the Flatpak per default, I don't know. I think in the installation, they just copy the files from the DVD on the target installation image. So, and this is why the system is not upgraded, the core system. And so this is why we run this system core upgrade manually. So, and again here, we can now, for example, distrobox is installed per default. So ls, and we have no distroboxes available. Create --name tumbleweed box -- hostname tumbleweed box and -- image tumbleweed, but we don't have to give tumbleweed normally. So just creating a distro box, and this is how I would initialize a fresh installation. So this command is already running, so half of the packages are upgraded, and then the top command. Here you can capital Z, enable color output, type H, capital H, and then 1 to 7 the colors, and then you have colorful output. With T you change the CPU to a bar, with M the memory to a bar as well, and with capital W you write the configuration so it's reloaded after opening top again. So the system load is 4. It's very hard working, but we come to an end here. And now we can enter tumbleweed. One is here, tumbleweed distrobox. We initialize the tumbleweed distrobox, and then we have it. So this is really a heavy deep dive. I don't plan it so long, but I don't care that much. I just want to show some other stuff on my channel. Maybe it's interesting for some folks. I don't think that anybody is reaching this point here, but the time marks in the video are good to switching between some topics. Okay. Oh, system load is 7 now. Yeah, because we do both in system upgrade and the distro box at the same time. Heavy working here. Let's create new profile, appearance. And then let's do transparency here. And then this is more likely. Toolbars shown. Settings toolbars shown. I don't like the toolbars here. I want the basic terminal. And then we see, oh, heavy working here. So let's check the system upgrade is nearly finished. And we also should df-h 6 GB already available. Uptime name -r btrfs echo alias d .bash rc d. And now if we open a new tab, we have directly the system overview with disk usage. This is good. And we have the system load as well. We could also grab pretty etsy OS release MicroOS. Okay, the distrobox is finished. System upgrade is nearly finished. Post run script. Let's check. 5.8 GB available. And now in the distrobox we can sudo zypper install fast fetch figlet and htop. htop, I don't need this, but let's install FEDORA, for example. And so we just use the system upgrade and use the distrobox. Okay. And now we can use the distrobox-export command --app FEDORA. And now we have here FEDORA on Tumbleweed. And we have here Tumbleweed box. I don't know why we now have two tumbleweeds. I have to check this. Okay. Okay, the zypper upgrade system core system upgrade is finished. And now zypper clean packages. Okay, df-h. Okay. And now we could also zypper in fast fetch and then figlet we could install. We also could install Firefox into the core system, for example, so we don't need the flatpaks. I also made an installation with MicroOS where I deleted all the flatpaks and installed every packages in the core system. This is also possible. If you want this, many things are possible. So I don't know, NNN file manager, Ranger file manager, but I don't want it in this case. 3 for the terminal is nice. And then yeah. Okay, so but what is good is about the transactional update shell. You execute multiple programs and then you just exit the shell and then you have this. And then df snapper list and now you see we have 2 snapshots. And I could start a shell again, -- continue. And I want to try this. Can I get directly zypper in sudo policy sudo dash policy let's check groups then okay. Super n sudo policy sudo out self. And now you see we have a problem, and now this is the solution. You can directly install sudo and sudo policy sudo authentication, and then solution is deinstall run 0 wrappers, and this is a graphical pop-up which you have seen. The problem is here the graphical pop-up is always popping up with any command, and if you use the sudo command in the terminal, you can you have a specific time where you don't have to type the password again and can work much faster. Okay, and so I choose the solution 2 and deinstall the run 0 wrapper, and then we get directly sudo access, and then I will just do user modify, and then dash add a ag at group sudo for user dan, and then we have, let's do grep dan etc sudo no group. Now we see dan is in the user in the sudo group, and then we have to execute the vi sudo command as well, I think, and let's check here, and then you see we don't have the let's do here sudo for the sudo group, so we can use the sudo group for all read drop in files. Maybe we don't need this here. Right quit ls etc sudo, what is here? Nothing here. Okay, sudo, and then let's out comment this, and then right quit, and then we have this also exit the shell, and then the snapshot is here, and now we have this snapshot. Okay. Yes, correct. And we use the dash continue option, so we made a snapshot of the second snapshot. This is correct. And now we can reboot the system, and then we will see that the system is upgraded. Here are the snapshots, and the kernel 7 is in, and let's start. And now we see system is upgraded, but we don't have directly the graphical login. And this is what we only can do with, and now we have to change this in the core system. In the core system, we have to execute a shell again. Now you see we have the sudo command here, and now we have a transactional-update shell. And now we do systemctl enable sddm, and now you see it's not possible within the snapshot. Sudo systemctl enable sddm. Okay, I think dash false, And now we have set the sddm. Sudo systemctl reboot. But now you will see I executed at least enabling sddm. We restart, but you will see that sddm will not start normally, because I did this just in the running system and not in a new snapshot. But I'm surprised sddm is starting. Now we get the Plasma desktop. Here we are, and now we can also do sddm, and now we can go to behavior and then automatically log in with Dan is enabled. So we let this here. I don't know why the auto login was not successful, but okay. Okay, so discover. We have some updates for Flatpak. Now we see tumbleweed boxes here, featherpad is here, from the tumbleweed box, kcalc, and Firefox, because the updates was system update was executed, refreshing firmware updates. 5 GB available, kernel 7 is running. Yeah. And now you see we don't get the graphical pop-up. We just directly type in the password in the terminal. Now we have the snapshots here. And now if we want so, we could delete also some snapshot. Sudo snapper delete. No, and then you could also delete snapshot 1, for example, or snapshot 3. And then you see this is this one. And yeah. Okay. Flatpak list. Okay. Feather per tumbleweed box. Starting container. Okay. Not sure. Distrobox-export. Okay, we have two containers here. I don't know why, but tumbleweed. Okay. Yeah. Sudo seperated. Okay. Yeah. That's it. So we can remove one tumbleweed box. Remove distrobox, remove tumbleweed. Now we have only tumbleweed box here. Okay, that's it. Correct. Okay, this is way too long. We do this here. I show just the system information again, and now we see we have here openSUSE MicroOS 2026 May 24 kernel 7. So this is what we wanted. We reached our goal. This is a fresh installed system, and yeah, it's working. I'm fine, and I stop the video here, and in future I go back to more Debian stuff, but just to show some skills about the immutable system. And the similar is with FEDORA Silverblue, but there the commands are different. There you use rpm-ostree, for example, but it's working well. It's all possible. Okay.